Good morning children, explaining you the current electricity lesson 2 of the chapter number 3. In my lesson number 1 I have already talked about conductivity, so I'm not going to talk about it. Today my first topic would be the temperature dependence of resistance. Color code of carbon resistors I have talked, so today I'll not talk about it. EMF and potential difference of a cell I'll talk about today. Internal resistance of a cell I'll talk about. Series and parallel combination of cells I'll talk about. Series and parallel combination of resistors requires another lesson, another period. So today I'm not going to talk about it. So let's begin. So first I'll talk about drift velocity. The rho is the resistivity, I the current, E the electric field, J the current density, and V the potential difference. Rho is equal to E by J. J is the current density, so it will be nevd. J is incidentally, already I talked about, J is incidentally equal to I by A. I is equal to nevd divided by A, so it will be Ne into Vd. Therefore Vd would be equal to E by Ne rho, or Vd is equal to V by Ne rho into L. Here E I am replacing by V by L. So you can see J is equal to I by A and E is equal to V by L. When temperature increases, the drift velocity Vd also decreases. So rho will increase. I repeat, when temperature increases, drift velocity decreases because rho increases, and when I increases, Vd decreases. So these are important concept for 1 mark question. I talk about conductance and conductivity. Conductance is the reciprocal of resistance. Its SI unit is ohm inverse, or in other words you can say it's mho. Conductivity is the reciprocal of resistivity. Its SI unit is reciprocal of resistivity, that's it, ohm inverse, meter inverse, or mho per meter. Temperature dependence of resistance. Already I talked about R is equal to m by Ne square tau L by A. In my lesson number 1 I have talked about it. Now rho is equal to m by Ne square tau. When temperature increases, the number of collision also increase due to more internal energy, and relaxation time, that's why, decreases. Because the RMS velocity is directly proportional to root over absolute temperature. So temperature increases, RMS velocity increases, so the relaxation time will decrease. Therefore resistance will increase. Remember, this is meant for only the metallic conductors. Temperature coefficient of resistance, let me talk about. As you understood, for a metallic conductor, with a rise in temperature, the resistance will increase. So temperature coefficient of resistance will be written as alpha. It is written as alpha equal to RT minus R0 by R0 into T. What is RT? RT is the resistance of the conductor at T degree centigrade. R0 is the resistance of the conductor at 0 degree centigrade, and T is the rise in temperature, T minus 0. Or you can say alpha is equal to R2 minus R1 if it is not R0, say R2 and R1, they are respectively the resistances at temperatures T2 and T1. So alpha can also be written as R2 minus R1 divided by R1 T2 minus R2 T1. R0 is the resistance at 0 degree centigrade, R1 is the resistance at T degree centigrade, R1 is the resistance at T1 degree centigrade, and R2 is the resistance at T2 degree centigrade. If R2 is less than R1, then alpha is negative. That it will show that there is a fall of resistance with temperature. Now I talk about sources of EMF. Sources of EMF are basically known as battery or cell, but it is the dynamo also. The sources of EMF, the electromotive force is the maximum potential difference between the two electrodes of the cell when no current is drawn from the cell. Remember, EMF is not electromotive force. It is not a force. It is rather energy available per unit charge. Please remember, this is a misnomer. EMF is not force, but it is energy available per unit charge when there is no current is being drawn. Let us compare EMF and PD. EMF is the maximum potential difference between the two electrodes of the cell when no current is drawn from the cell, that is when the circuit is open. Potential difference, also called terminal PD, is the difference of potential between any 2 points in a closed circuit. Closed circuit means when the current is flowing. EMF is independent of resistance of the circuit. Potential difference is proportional to the resistance between the given 2 points. Also, it will be in Ohm's law. The term EMF is used only for the source of EMF. It is when terminal PD or PD is the measure between any 2 points of the circuit. EMF is greater than the potential difference between any 2 points in a circuit. Remember, this is meant when there is no external power source is being applied, means there is no charging taking place. Potential difference is greater than EMF only when the cell is being charged. Otherwise, terminal PD is less than EMF. Now let's watch a small video on the working of primary and secondary cells.
Reactions. It pumps electrons along wires, namely positive ions or cations and negative ions or anions. These types of solutions form the electrolyte of a cell. Metal rods immersed in electrolytes act as electrodes. The positive electrode is the anode and the negative electrode is the cathode. These electrodes attract oppositely charged ions, resulting in flow of electrons. The dry cell is a modification of the wet Leclanche cell. The parts of a dry cell may be understood by observing the vertically cut section of the cell. The anode is a graphite rod. Graphite is a form of carbon. The zinc container is the cathode. The electrolyte is a moist, jelly-like paste of ammonium chloride and starch enclosed in the metal cylinder as shown here. A mixture of manganese dioxide and powdered carbon surrounds the graphite rod. The jelly is prevented from drying up by sealing the top of the cell with pitch or asphalt. A cardboard washer is used to prevent the graphite rod from coming in contact with the zinc can. This is referred to as the spacer. The zinc can is surrounded by an insulating thick paper covering. The positive terminal of the cell is a brass knob at the top, while the negative terminal is at the base. The chemical reactions that takes place inside the cell are quite complex. The simplified reactions are given here. At the zinc cathode, zinc metal is oxidized to positively charged zinc ions, releasing 2 electrons. These electrons are collected by the graphite anode. The reduction reaction at the graphite anode is represented here. This flow of electrons produces electric current. This dry cell produces a voltage of about 1.5 volts. Nickel-cadmium cells are rechargeable cells.
Well, this is a small video clip I have taken from the tutorvista.com. So children, as you understood that there are 2 kinds of cells. One is primary cell, which is not chargeable, and another is secondary cell, which is chargeable. That means it can be recharged. Internal resistance of a cell, let me talk about. The opposition offered by the electrolyte of the cell the flow of electric current through it is called internal resistance of the cell. Now, the factors that is affecting the internal resistance of the cell are the separation between the electrodes. So separation means larger the separation between the electrodes of the cell, more the length of the electrolyte through which current has to flow, and consequently higher value of internal resistance will be coming. The greater the conductivity of the electrolyte, lesser the internal resistance of the cell. That is, internal resistance depends on the nature of the electrolyte. That's an important thing. This also decides whether it is a primary or secondary cell. Primary cell has got a one directional chemical reaction for which the internal resistance will be higher. For the secondary cell, it is a reversible reaction, so here the internal resistance will be a little lower. I'll talk about it. The internal resistance of the cell is inversely proportional to the common area of the electrodes dipping in the electrolyte. Inside the electrolyte, whatever is the area of the two electrodes, if the electrodes are not of equal size, you have to take the common area of the electrodes. Here I'll talk about EMF. E is equal to V plus V. What is capital V? Capital V is the potential difference across the external resistance, as small v is the voltage lost within the cell. So you can write this as IR plus I into smaller. I is the current drawn, so I is equal to R plus R. Or in other words, you can say I is equal to E. This E means it is EMF divided by R plus R. This relation is also called the circuit equation. In fact, the internal resistance of a cell also depends on the nature of the electrodes. That is also deciding whether it is a primary or secondary cell. One point I told you that for primary cell the internal resistance is larger, and for secondary cell the internal resistance is smaller. Like say I talk about lead acid cell. For a 2 volt lead acid cell, the internal resistance is of the order of 0.01 ohm, but whereas for 1.5 volt Lagrange cell, which is a primary cell, its internal resistance will be of the order of 10 ohm to 50 ohm. So the difference is quite large, and that depends on the nature of the electrodes used and the electrolyte that has been used. I show you how it is in circuit diagram. It is represented. EMF E, smaller is the internal resistance, capital R is the external resistance. I is flowing, the potential drop across the cell, inside the dotted box, that is called the lost volt, and capital R is the terminal P. Across the capital R, that is V, is equal to I into capital R, that is known as terminal PT. Now I talk about internal resistance of a cell in terms of E, that is EMF, terminal PTV, and capital R, the resistance, external resistance collected. So once again the same expression I will show you. E is equal to V plus V. Capital V is the capital V is the terminal PD across capital R, and small v is the lost volt, that is the potential difference across the battery. So I into R is equal to E minus V is the EMF, V is the terminal PD, dividing both sides by I into R. I into R is equal to V. We'll get I into R divided by I into capital R, E minus V by V. So the expression comes out to be smaller, that is internal resistance, equal to E by V. E is the EMF, V is the terminal PD minus 1 into capital R, the external resistance, which is connected in series with the cell. Determination of the internal resistance of the cell by the voltmeter method. Here I need to tell you one important thing, that voltmeters cannot measure the EMF. It can only give you the near perfect value of the EMF, but actually it cannot give the terminal, it can give the terminal PD, but it cannot actually give the EMF. The reason is the voltmeter still have some finite resistance, so some current will be still flowing through the battery. So I'm showing you the diagram. The diagram V is the voltmeter. Here when the battery is connected, you will be getting the terminal PD, and when the battery is open, when the no current is drawn in the first diagram I am showing you, then the EMF or nearly equal EMF will be shown, and then you will be putting the value of E and V, and capital R the resistors of the resistance box. You will be getting the internal resistance, approximate value of the internal resistance. The help of these we can find out the internal resistance. Now I'll talk about the cells in series combination, or you can say this is series grouping. Remember, a number of cells together is also known as a battery. So when the cells are connected in series, when it is connected positive to negative end to end, then it is known as a series grouping. Let's see. So there are 3 cells being connected here across a capital R. You can see the same current is flowing through them. The terminal PD is capital V. So you can see the EMF of the battery is the sum of individual EMFs. The current in each cell is the same and is identical with the current in entire arrangement. The total internal resistance of the battery is the sum of the individual internal resistances. Here it is a supposition, it is not always true. And total EMF of the battery will be N into E. E is the EMF of each cell, N is the number of identical cells. The total internal resistance is N into R. So total resistance of the circuit is NR plus capital R. So you'll be getting I is equal to NE by NR plus capital R. That is the I series. So if R is very much less than NR, then I is equal to E by R. But we have used N number of cells, so the current should be higher. So R is very much less than NR. This condition is not valid for series combination. But if NR is very much less than capital R, that means the external resistance is larger. I is equal to N into E by R, which is a valid equation. So remember, series combination or series grouping is used for the resistances, the external resistance is much larger than the total internal resistance. That is, when internal resistance is negligible in comparison to external resistance, then the cells are connected in series to get the maximum current. Similarly, I will be telling you about when a number of identical cells connected in parallel combination, or you can say it is parallel grouping. The cells are said to be connected in parallel when they are joined positive to positive and negative to negative, such that the current is divided between the cells. Current is divided between the cells depending on the cell criteria, like what is the value of smaller and E. But here I have taken all of the cells are identical, so equal current will be there. So you can see E and R, E and R, E and R, n number of times they are connected in parallel. The total current that will be sent through the external resistance capital R is IC. Now let us see some notes on it. Number 1, the EMF of the battery is same as that of a single cell. That is already told. The current is in the external circuit is divided equally amongst the cell. So capital I is equally divided across each of the cells. The reciprocal of the total internal resistance is the sum of the reciprocal of individual internal resistance, because they are connected in parallel. So you'll be using 1 by R is equal to 1 by R1 plus 1 by R2 like this. And total EMF of the battery is E, because they are all connected in parallel. Total internal resistance of the battery is small r by n. That is, n number of times small r is connected in parallel, so the resistance will become r by n. So total resistance of the circuit will be capital R plus r by n. Then what will be the current? The current I is equal to NE by NR plus R. An interesting point, When NR is very much greater than smaller, that is, if external resistance is larger than the internal resistance, then current will be NE by NR, that is E by R, that is current drawn from one cell, which is not suitable. But in case R is very much less than R by N, that is external resistance is small, in that case we will be using I is equal to NE by NR plus R, NR plus R, but NR will be negligibly small, so NE by R, that is current will increase to N number of times. I hope you liked my video on current electricity today. Don't forget to collect my notes on the topic from the description of the YouTube video, and try some quiz questionnaires for which the link is given at the bottom. Don't forget to like in case you liked the video, and subscribe if you have already not subscribed. Keep well and try to utilize the lockdown time to its maximum. Thank you all.